Hello everyone, welcome to our channel Off Campus. Before going into the video, please subscribe our channel Off Campus and click on the bell icon. You will receive notifications as and when we upload videos. In this video, we are going to see some question and answers in analog to digital converter and digital to analog converter. Let's start. First one. First question. DA converters, digital to analog converters are generally weighted resistor network, binary ladder network, either A or B, neither A nor B. Option, the right option is solution B, binary ladder network. Next question number 2. In a 4-bit DA converter, the offset error is the output voltage when the input voltage is 4 different options are given. The input voltage is nothing but option B 0000. Okay, then move on to the next one. Which is known as a flash converter? Which is known as a flash converter? We know that parallel AD converter, which means that this is the another name of flash converter. Parallel AD converter is the flash converter means parallel AD converter. So option B is the right option. Flash AD is the fastest of all DA converters. Sorry, AD converter. It is analog to digital converter. It is not DA. AD, analog to digital converter. Okay, flash converter will come under analog to digital converters and uses 2 power n minus 1 comparators. Number of comparators is 2 power n minus 1 comparators. It is very expensive. Okay, it is very expensive. So parallel converter, another name of flash converter is nothing but parallel AD converter. It is the fastest among all analog to digital AD converters and uses how many comparators are needed? 2 power n minus 1. It is very expensive. Then move on to the next question. Which converters uses integrating op amp? Which converters uses integrating op amp? Parallel AD, single slope AD converter, dual slope AD converter, both B and C. So option is dual slope AD converter uses the integrating op amp. So what is that? Here explanation given. The core of the dual slope AD converter is the integrating op amp. Integrating op amp, which converters uses the integrating op amp is nothing but dual slope AD converter. It uses what is that? Integrating op amp, and thus it has good noise immunity and its accuracy is very high. Accuracy and noise immunity, it is the advantages of that dual slope AD converter. It requires 2 into 2 power n. This 2 into 2 power n. 2 power n twice the ramp type clock cycles for conversion. If anything asked like maximum conversion time or something, we need to use 2 into 2 power n or 2 power n plus 1. Okay, this is the formula for finding out the maximum number of conversion time. Okay, then question number 5. The accuracy of analog to digital conversion is, what is the accuracy? Accuracy is nothing but, so I am doing some, it is 1. Okay, accuracy is solution A. Accuracy of AD conversion is generally option A plus or minus half LSB, least significant. It is half of the resolution of AD converter. Accuracy is half of the resolution of AD converter is nothing but option A plus or minus half LSB. Then question number 6. The number of counter states which an 8-bit stair step AD converter has to pass before conversion is. The number of counter states for 8-bit RAM type. We need to find out the number of counter states for 8-bit RAM type AD converter is nothing but, what is the formula? 2 power n. So 2 power 8 is not equal to 256. Option D 256 is the right answer for this question. Next one, question number 7. An n-bit ADC using V reference has a resolution of, it is a resolution formula. Resolution formula is nothing but V by 2 power n minus 1. Okay, option C, V by 2 power n minus 1. Okay, What is the explanation here? Its successive binary count is equal to 1 by 2 power n minus 1 of the total. So, the resolution of n bit is V as the reference voltage. So, V divided by 2 power n minus 1. Resolution of the n bit ADC using V as reference is nothing but option C, V by 2 power n minus 1. Then question number 8. A 6-bit ladder DA converter has input 101001 for 1 represent in that binary digit, 1 represent 10 volt and 0 represents 0 volt, 0 equal to 0 volt where 1 equal to 10 volt. The output is, we need to find out the output. What is given? The binary input is given, binary data, and how many bits? 6-bit ladder, and the voltage range is given. So, for a 6-bit DA converter whose output varies from 0 to 10 volt. See, 0 to 10 volt. The resolution is nothing but 2 power here. Resolution equal to 10 divided by, see, it is not 10 divided by maximum voltage. Previously we have seen one formula na. What is the formula for resolution? V divided by 2 power n minus 1. So, what is the V? V is the reference voltage. Here voltage is varies from 0 to 10 volt given in the question itself. So, maximum voltage is 10 volt. 10 divided by 2 power n minus 1. N is the number of bits. Here given as 6. Then 2 power 6. 2 power 6 minus 1. When we solving this, we will get 10 divided by 63. Here 10 divided by 63. 2 power 6 what ma? 64. 64 minus 1, 63. So, 10 divided by 63 is 0.1587 as a, it is the resolution. We need to find out the, what we need to find out? We need to find out the output. Okay, resolution, what is the resolution? How to find out the output from the resolution? We need to take the binary, decimal equivalent for the given binary number and multiplied with the resolution, we will get the output. So, this is the concept. What is given? What is the first? We need to find out the resolution. What is the formula for resolution? V reference divided by 2 power n minus 1. Before we have seen. What is the formula? V divided by 2 power n minus 1. Okay, what is V? V is 10 volt and 2 power n, n is a number of bits. Okay, so apply these values in that formula. We will get 10 divided by 63 as 0.1587. So, this is the resolution. What we need to find out? We need to find out the output. How to find out the output? What is the what is the resolution? Resolution is the smallest analog change in the output or a change in one LSB. So, we need to find out the decimal equivalent for this binary given binary value. This is 2 power, what is the decimal equivalent? 41. This is base 10. Okay, this should become as subscript. Okay, ma? Okay, 41 base 10. What is the decimal value here? 41. Then multiplied by with resolution. So, 41 into the resolution value, we will approximately get 6.51 volt. Option B, 6.51 is the right option. First, we need to find out the resolution using that formula V divided by 2 power n minus 1. Then we need to find out the output. How to find out the output? Output is nothing but a binary equivalent value for the given, decimal equivalent for the given binary value input, binary input, and then multiplied with the resolution, we will find out the output. Okay, then move on to the next problem. A 10-bit DA converter given a maximum output of 10.23 volt. The resolution is. So, we need to find out the resolution. We know that what is given, number of bits given and maximum output voltage is given. So, we know the formula for resolution. Resolution is nothing but 10 V divided by 2 power n minus 1. What is V? Maximum output, V reference, maximum voltage 10.23 divided by 2 power n minus 1. What is the number of bits? 10. Okay, 2 power 10 minus 1. So, we need to simplify 10.23 in the numerator, in denominator 2 power 10. What is the value? 1024. 1024 minus 1, 1023. So, 10.23 divided by 1023, we will get the value as 10 millivolt. Okay, 10 millivolt. So, option A, 10 millivolt is the right option. We need to know that we should know about the formula for resolution and the how to find out the output voltage for the given binary equivalent given binary input, because this is the very important in that in case of DA converter. Next one, maximum conversion time for 8-bit ADC, analog to digital converter, in clock cycles. We need to find out the maximum conversion time. So we different types of analog to digital converter is given. Which one? Successive approximation and dual slope, and what is that? Parallel comparator. We need to know how to find out. We will see. First we need to, what is the formula for? We have different formulas. We have formulas for each and every types to find out the maximum conversion time. First of all, successive approximation type, how to find out the maximum conversion time in clock cycle? It is n clock cycles, where n is a number of bits. Then for dual slope is nothing but 2 into 2 power n. See, it is 2 into 2 power n. 2 power n time clock cycle. Okay, this is time clock cycle, which is nothing but 2 power n plus 1. 2 into 2 power n is nothing but 2 power n plus 1 time clock cycles. Okay, this is a formula. Then parallel converter, it irrespective of the number of bits, for any number of bits, what is the maximum conversion time for parallel comparator? It is nothing but 1 clock cycle only. Okay, 1 clock cycle only. Okay, this is the formula for successive approximation, n clock cycle, dual slope 2 power n plus 1, or 2 into 2 power n clock cycle. For parallel comparator, 1 clock cycle. Okay. Then first one, for successive approximation, what is the formula? Successive approximation is nothing but n clock cycle. What is the n here? N is given as number of bits as 8. So for successive approximation n clock cycle, nothing but 8 clock cycle. So for option for A, it is 2, A matched with 2. Okay, then dual slope, what is the formula? 2 power n plus 1. So 2 power 8 plus 1. 2 power 8 plus 1 is nothing but 2 power 9. What is the value of 2 power 9? 512 time clock cycle. So 512 for B, option 5. Then parallel comparator, irrespective of number of bits, the maximum conversion time is 1 clock cycle. That is nothing but C, option C, 1. Okay, option A 8, option B 5, option C 1. Okay, this is the correct option for this problem. Then next one. So here given question number 7, for an ADC, match the following. If list 1 and list 2 is given, we need to match the list 1 with list 2. So first of all, what is in the type of ADC is given? Flash converter, dual slope converter, successive approximation converter. So what is the functionality? Depending on the functionality or advantages or specifications, we need to match with A, list 1 with list 2. So given, I am just reading out the list 2, requires a conversion time of the order of a few seconds, requires a digital to analog converter, minimize the effect of power supply interference. Okay, requires a very complex hardware, is a tracking AD converter. First in list 1, what is flash converter? In flash converter, the match with which one is, it requires a complex, very complex hardware. Flash converter is the what is the other name? See here, flash converter, other name is parallel AD converter, is fastest among all of the converter. It is the fastest one, but what is the disadvantages for this flash converter? It requires a complex hardware. So flash converter matches with requires a very complex hardware. Flash converter, what are the advantages and disadvantages? Flash converter, what is the another name? Parallel AD converter, it is the fastest one, but what is the disadvantages? It requires a very complex hardware. Then dual slope converter, what is the dual slope converter, or it can, which one? What is the advantage? First of all, we will see good noise immunity and minimizes the effect of power supply interference. Actually, dual slope integrator advantages is has good noise immunity and thus minimizes it has good noise immunity, so it minimizes the effect of power supply interference. So dual slope converter minimizes the effect of power supply interference. Then move on to the next one. What is that? Successive approximation converter. What is successive approximation converter? It has shorter conversion time of the order of microsecond and depends upon the number of bits only. Okay. For an n bit ADC, it requires n clock cycle. It uses DA converter. So what are all the specifications? What are all the specifications of successive approximation? It has shorter conversion time, order of microseconds, see microseconds, and depends on the number of bits only. Okay, number of bits only. Okay, then for an n bit ADC, it requires n clock cycle. Previously we have seen for n bit it is n clock cycle, maximum n clock cycle. See, for successive approximation n clock cycle, for dual slope 2 power n plus 1, parallel 1 clock cycle. So for successive approximation it requires n clock cycle. It uses digital to analog converter. Successive approximation actually analog to digital converter, but it uses a digital to analog converter. Okay, then successive approximation converter, which one? It requires a digital to analog converter, SAR. In short, in SAR requires a digital to analog converter. So we will match again. Flash converter requires a very complex hardware A with 4. Then dual slope converter minimizes the effect of power supply interference B with C, whereas successive approximation converter requires a digital to analog converter, C to true. Okay. Then move on to the next one. The advantage of using a dual slope ADC in digital voltmeter is that 4 different options are given. What is that? Conversion time is small, accuracy is high, it gives output in BCD format, it does not require a comparator. So which one? The advantages of dual slope ADC is nothing but accuracy is high. Option B, accuracy is high. Then move on to the next one. It is what is given. See, and it is a problematic question. An 8-bit successive approximation analog to digital converter has full scale reading of 2.55 volt and its conversion time for an analog input of 1 volt is 20 microseconds. The conversion time for a 2 volt input will be, what is given? First of all, it is a n bits SAR type, SAR successive approximation analog to digital converter. Full scale reading voltage is given as 2.55 volt. It conversion time for input 1 volt. For input 1 volt, what is the conversion time? 20 microsecond. We need to find out the conversion time for 2 volt input. For 1 volt input, the conversion time is 20 microseconds. For 2 volt input, what will be the conversion time? See guys, we know that we previously seen the successive approximation type clock cycle. What is the formula? N clock cycle. It depends on the number of bits only. Okay, it depends on the number of bits, not on the input. Okay, not on the input value. It depends. It's totally depend on the number of bits. So if n bit, it is some n clock cycle. Okay, then if we change the input voltage, that doesn't affect. Okay, conversion time will not get affect. Okay, then what is that? When we changing the two input voltages, the answer is same only, 20 microseconds only. The conversion time needed for 2 voltage for 1, irrespective of input voltage, it will be the same. What is given? 20 microseconds. Option B, 20 microseconds is the right option, because it will depend on the number of bits. Okay, we'll see the conversion time of successive approximate ADC depends upon the number of bits only. Number of bits only, not on the number, not on the input value. Okay, are we clear? We'll move on to the next one. The number of comparators in a 4-bit flash ADC. This is very important question. We will asking very frequently in all of the competitive exams. Okay, the number of comparator is nothing but 2 power n minus 1. Okay, the general formula is 2 power n minus 1, 2 power n minus 1. Okay, the number of comparator, number of for 4-bit flash. So where n is the number of bits, 2 power 4, what is that? 16, 16 minus 1, 15. So the number of comparators for in a 4-bit flash ADC is nothing but option C, 15. Then move on to the next one. What is that? 16. A digital system is required to amplify a binary encoded audio signal. The user should be able to control the gain of the amplifier from a minimum to a maximum in 100 increments. The minimum number of bits required to encode in a straight binary. Okay, straight binary. We need to find out the straight binary. It is 2 power n. It should be greater than 2 power n greater than 100. So what is the n? If n is 2 power 7, what is the value? 128. So 2 power 7 is 128. 120 is greater than that increments. What is, how many increments? 100 increments. So the number of bits required is 2 power 7. If we use what is the 2 power 6, what is the value of 2 power 6 is 64. It is below the given increment. So it should be greater than the given increment. So 2 power 7 is nothing but 128. So it is greater than 100. So n is, we need to, what is the n? N equal to 7. Greater than equal to 7. Okay, the minimum number of bits. See, the minimum number of bits is required to encode is nothing but 7. Which one option? Option D, 7 is the right option for this problem. Okay. Okay, thanks for watching this video. If you like, share, subscribe our channel and click on the bell icon. You will receive notifications. Thank you.